Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the same book Modern Physics by Paul A. Tipler. As usual we first come to its statement. Okay. An electron with rest energy of 0.511 million electron volt moves with speed u equal to 0.2 c, where c is speed of light, which is usually taken as 3.0 into 10 raised to the power 8 meter per second, or sometimes 2.998 into 10 raised to the power 8 meter per second. Okay. Find its total energy, kinetic energy and momentum. Yes students, we have to find out three things. Okay, total energy, kinetic energy and momentum. Okay, in order to find out these three things, we will take resort to a lot of snapshots from different books. Okay, which will provide us a guideline regarding the solution of this problem. Okay, so we discuss these snapshots shortly, one by one. Okay, first snapshot is about Lorentz factor. Okay, Lorentz factor gamma is equal to 1 over under root 1 minus u square over c square, where u is the speed of one frame of reference relative to another, while c is the speed of light in vacuum. Okay. Second snapshot deals with total energy. Okay. Second snapshot says the total energy E of a particle is given by E equal to mc square over under root 1 minus u square over c square, and it can alternatively be written as equal to gamma mc square. Okay, where gamma is the Lorentz factor, as discussed in snapshot number 1. In third snapshot, we are going to mention or discuss or specify kinetic energy. Okay, the relativistic expression for the kinetic energy of a particle is k is equal to mc square over under root 1 minus u square over c square minus mc square, and this can be alternatively written as being equal to gamma minus 1 within bracket into mc square. Okay, what we have done? We have taken mc square common from both these terms, and hence after taking mc square as common, it has taken the shape as gamma minus 1 into mc square. Our next snapshot deals with relativistic momentum. Relativistic momentum P is equal to mu over 1 minus u square over c square whole under root. Okay. Our next snapshot deals with the relation for total energy, momentum and rest energy. Okay, E square equal to P square C square plus MC square whole square. Okay, so dear students, using these snapshots in accordance with the philosophy conveyed by these snapshots, we are going to solve our problem. Okay, first we find out the value of gamma, Lorentz factor. Okay, so gamma is equal to 1 over 1 minus u square over c square. Here in place of u we will put the value 0.2 c. Okay, here c square will be cancelled out with c square, and we will be left with gamma being equal to 1 over 1 minus 0.04. This alternatively becomes equal to 1 over under root 0.96, and when we take under root of 0.96, it becomes equal to 0.98, and when we treat 0.98 as a reciprocal of unity, then it becomes equal to 1.02. Okay, hence our Lorentz factor gamma has become equal to 1.02, benefit of this step is that in next steps we will not find the value of gamma. Okay, we will directly put value of load and spectral gamma. Okay, now we come towards the second expression, that is total energy. E equal to K plus mc square. This alternatively becomes equal to mc square over 1 minus u square over c square under root, and this alternatively becomes equal to gamma mc square. We have found the value of gamma in our previous step, so we put the value of gamma, that is 1.02, and we know that value of mc square has been provided in the problem, which is 0.511 million electron volt, and hence in this way our value of energy, total energy, becomes equal to 0.52122 million electron volt. Okay, dear students, we can find this value by another method. Okay, because we have introduced several snapshots, so in accordance with the philosophy conveyed by these snapshots, we can solve a part by more than one method. Okay, how, and answer will also be if not exactly equal, it will be nearly equal. Okay, now we use the second method. Okay, second method is E square equal to PC square plus MC square whole square. Here we have used the value of PC equal to 0.100 million electron volt. Actually, dear students, this value which we have used will be found in a later part of this problem. Okay, but here in order to counter check our problem, we have used this value 0.100 million electron volt. Okay, value of PC. Actually, we have found this value in next part of this problem, but here in order to counter check our solution, we have directly put this value here. First I go to that part where we have found this value. Okay, yes, we have found P from here. We have found the value of P here. From here we have found the value of relativistic momentum P, and its value has been used there in order to counter check our problem. Okay, so total energy is equal to PC square plus MC square. Value of MC square is given in the statement, while this value we have found in the later part of this problem. However, here we have used that value. Okay, so its square plus its square becomes equal to this plus this. It becomes equal to this 0.27 million electron volt whole square, and when we take under root on both sides, then E total energy becomes equal to 0.5196. If we keep it to two decimal places, then it will be taken as 0.52. This is also 0.52. Okay, so both values have tallied, reconciled, etc. Now we come towards kinetic energy. Okay, sometimes we denote kinetic energy by simply K, sometimes we denote it by kinetic energy in this way. That is, energy is by capital E and K is written as a subscript of V. That is kinetic energy. Okay, E, K, where K is written as a subscript of E. Kinetic energy Ek is equal to mc square over 1 minus u square over c square under root minus mc square. It becomes alternatively equal to gamma minus 1 mc square. We have found the value of gamma in first step of this problem, which is 1.02 minus 1 into this value is given in the statement, okay, 0.511, and hence kinetic energy finally becomes equal to 0.01022 million electron volt. Okay, kinetic energy. Now perhaps we are going to know, we have not used another method, that is enough. Now we are going to find the value of momentum P. Momentum P is equal to mu over 1 minus u square over c square. Okay, here value of m is this. Actually, dear students, value of mc square is given in the statement, and from that we have taken the value of m by when mc square is equal to 0.511 million electron volt, then m will become equal to c square will be shifted to other side of equality, and c square, which is being multiplied with mass m, will be divided by shifting on other side of equality, and hence in place of m we will get 0.511 million electron volt over c square. Okay, because we have value of mc square equal to 0.511 million electron volt. Okay, moreover value of u is also given in the statement as 0.2 c. Okay, moreover this is the Lorentz factor gamma. Okay, here we have directly used its value 1.02. okay, and hence after simplification our answer becomes 0.1022 million electron volt over c over 1.02, and hence this becomes equal to 0.100 million electron volt over c. Okay, what is this? This is the value of momentum P, and now we are going to counter check. We are going to find out the value of momentum P by alternate method. Okay, second method, E square equal to PC square plus MC square whole square is equal to, here in place of PC we have used this value, and in place this implies that here in place of E square, value of E is 0.52122 million electron volt. Okay, in place of E we have used this value 0.522122 million electron volt. Okay, here we have not touched PC square. Okay, PC square is the same as it is P square C square or PC whole square. Okay, no difference. Plus value of mc square is provided in the statement, which is equal to this. Okay, this implies that now we will keep p square c square on one side, and hence this factor will be shifted to other side of equality and it will be subtracted. Okay, hence p square c square equal to 0.2527 minus 0.26 million electron volt, p square c square is 0.01 million electron volt. Hence when we will take under root on both sides, then PC will become equal to 0.1 million electron volt. Okay, PC is equal to this, and hence P will be equal to 0.1 million electron volt over C. Okay, so dear students, here P is equal to 0.1 and here again 0.1. Okay, so both values of momentum are same, so our problem has been counter checked. Okay, and in this way we have found all the three values, that is total energy, kinetic energy and momentum, and hence this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.